Hey everyone. Today we're going to be talking about the golden ratio, also known as phi, because it can be denoted with the Greek letter phi, which you can write like this or like this. So the golden ratio, while it may not be everyone's most familiar math constant denoted by a Greek letter, of course pi takes the cake for that, but the golden ratio still has a variety of applications in numerous fields, such as architecture and design, to name a few, and it can also be seen a lot in nature. Many consider the golden ratio to have beauty in it, and to be in all the patterns and shapes that you can create with it to be visually appealing. Now take a look at this rectangle, for example. Doesn't it seem nice in a way, despite just being 4 lines? Doesn't it seem like it has the perfect proportions? Well, that's because at the heart of this rectangle is the golden ratio. In fact, the ratio of length to width of this rectangle is 1 to 5. And that's what makes it have a certain visually appealing character. But what really is the golden ratio? Well, to start with, it's just a number. The golden ratio, or phi, is equal to 1.618, and on and on and on and on. The digits never repeat and continue on forever, which makes phi irrational. More succinctly, we can define phi as this, 1 plus the square root of 5 all over 2. But that doesn't really give us a lot of information about how we got to it in the first place. For that, we can take a little experiment here. Say we have a line segment divided into parts A and B. Now, let's make an equation. If A plus B is to A as A is to B, we have the golden ratio itself. There's only one possible number that fulfills this equation. A plus B over A is equal to A over B. And that number is phi. Now, we can take this rather simple equation and manipulate it a little bit to get something pretty beautiful. Let's try to split apart A plus B over A. Well, A plus B over A is quite simply A over A plus B over A. And we know A plus A over A is just 1. That leaves us with B over A. Well, we know from this that A over B is the golden ratio, so B over A is just 1 over the golden ratio. So we have 1 plus 1 over phi is equal to A plus B over A. But what's A plus B over A? A plus B over A is the same thing as A over B, which is the same thing as phi. So we can define phi in terms of itself. Phi is equal to 1 plus 1 over phi. Well, I mean, the phi over here is nothing different than the phi over here. So we can define this phi as 1 plus 1 over phi. And on and on and on. You have this infinitely nested fraction, which is beautiful in and of itself. But we haven't even got to how it looks in shapes, in paintings, in architecture, and so much more. So where can we find it appear? Well, for example, this shape is the golden rectangle. Now it's so called because, just like our previous rectangle, it has a side length ratio of 1 to phi. And the special thing about it is, if you remove a square from the golden rectangle, then you get this rectangle right over here. Now this rectangle, it may not seem like it, but it also has the side length ratio of 1 to phi. And you can keep doing this forever and ever and ever, which makes it really neat. Now, because the golden rectangle is found visually appealing. You can see it and a spiral form of it a lot, basically everywhere, from Leonardo da Vinci's Vitruvian Man to his Mona Lisa, and even in the Parthenon. This over here is a golden rectangle, just like we had before. We can also find phi in nature. Using the golden rectangle and its infinitely descending scale, you can create a spiral, and the spiral shows up everywhere, from nautilus shells or the shells of other mollusks to entire galaxies, and even the arrangement of plant leaves. So truly, the phi is pretty universal. We hope you learned a lot about the golden ratio, its applications, and how to get to it in the first place. Thank you for watching.